Okay. Well, it's nice to see you guys again. Did you miss me? Yeah.
Oh, I was the only one who missed you. Okay.
I know it is.
I missed you
No,
guys.
you didn't. You enjoyed your weekend.
Well, I really did.
Yeah.
But yesterday was sad being here without you guys.
Well, obviously, this guy's enjoying my weekend still.
See that? You're still enjoying your weekend? I was not.
You had to work.
Yeah, I had to work. So it's much better to have students here than just to come by myself. So, Thursday, the last time we actually had class, we worked on distance and midpoint formulas and Pythagorean theorem. That was a math Excel assignment. Then today we are going to talk about functions and relations. So the big concept here, like if something's a function or not, you have done before. But there is a new piece. We're going to start talking about interval notation, how we're going to write our answers, and you have not seen that before. So I did print these notes for you today because there's a little more writings and definitions, and I wanted to give that to you. So what you've seen before, set builder notation, so those squiggly brackets, that just means the set of all x's where x is greater than -2. To be honest, you probably didn't even write that. You probably just wrote x is greater than -2. But I want you to see this because like ACT and things like that, sometimes they'll throw this notation on there, and I don't want it to scare you. All you're looking at would be that part. So things bigger than -2. In interval notation, it's a shorthand where you don't use the variable anymore, and we don't use inequalities. We put a starting and a stopping point. So if you think about x is greater than -2, if you were to graph that on a number line, you would start at -2, and would you have done an open or a closed circle? Open, and you would be going to the right. Okay, interval notation, we put a starting and a stopping point. We don't use open and closed circles anymore. We use parenthesis or a bracket. So since this is not equal to is a parenthesis, and it keeps going forever. So there's no stopping point, so we end at infinity. Infinity always gets a parenthesis. It's not a specific number, so we can't equal infinity. So it will always have that parenthesis, never the bracket. So the first thing I want to do is take this set notation and write it using the interval. Okay, if it helps you, you can draw yourself a little graph. That's not required. If you're drawing a graph, you don't have to do anything too fancy. You don't have to put like every number from -10 to 10 or anything like that. We don't use open and closed anymore. I'm going to stick with, I like to use one notation and stick with it. So for a closed circle, we'll use a square bracket. So this is saying it starts at 1 and ends at 3. So the interval notation, equal to means it gets a square bracket. You do your starting, comma, your ending, 1, 3. It has to go small to large, left to right. So you can't put 3, 1. Okay, order does matter here. What would B look like?
Parentheses. -4, 0.
Right, it's the same thing. You're in between -4 and 0, but you don't equal either of them. So they both get parentheses. So it'd be parenthesis, -4, 0. It's okay for one of these to be a parenthesis and one of them to be a bracket. If I had said -4 is less than or equal to x is less than 0, then the -4 would have a bracket and the 0 would still get a parenthesis. Okay, so you could have a combination of this. All right, C. X is greater than 5. So if you think about your number line, you're starting at 5, parenthesis, and it's everything larger than that. So you have to put a starting and a stopping point. So it would be 5, comma, where does this end? And infinity gets a parenthesis no matter what. D. X is less than or equal to 1. Yeah, but 1 gets in and we're going forever this direction. So that would be to 1, and the 1 gets a bracket. Are there any questions on this notation? Let's go the other way. So I'm going to give you the integral, and I want you to tell me what the inequality is. So A means you start at 1, you end at 4. How do we write that with an inequality?
1 is greater than or equal to x is greater than
1 less than or equal to x is less than 4. So it's saying the x is bigger than the 1 and smaller than the 4. The 1 got an equal to because it had a square bracket, the 4 did not. B. 2 to infinity. So that means you started at 2 and you went forever in the positive direction. So what would that be? Yeah, we could just say x is greater than 2. It's everything bigger than 2. All right, C. What would this one be? Both of them have brackets, so they both get an equal to. And D. Right, because it went forever in the negative direction. All right, questions? So that's the new piece, the integral notation. The rest of this is pretty well reviewed. We want to talk about functions, function notation, all of that kind of thing. So first we need the difference between a relation and a function. A relation is just some kind of relationship between them. They're related somehow. In algebra, you usually saw this as ordered pairs. You have an x and you have a y. A function is a special kind of relation where each input is associated with exactly one output. If it's a function, that means x never repeats. Every x value gives you one and only one answer. You never put in something and get two different answers out. When we're talking about functions and relations, we'll also talk about domain and range. Domain is your input or your x value. Range is what you get out, so your y value. So functions can be represented different ways or relations. The first one I have here is a table. So we're going to, for each of these, decide if it's a function and give the domain and range. So is a function? Why?
One more.
Yeah, 1 repeats. Okay, but we can still give the domain and range. Domain is just listing out your input or your x values. If you have the same thing multiple times, you only have to write it once. So my domain is 1, 3, 4. The range is what we get out. So what would that be?
2, 3, 4.
It does not matter what order when you're listing them like this. So I put it in increasing order, but if you had already written it and saw the 2 at the end, that doesn't matter. B, is this one a function?
Yeah.
We look, every x is different, so that's a function. What's my domain? Just the x value of each of those ordered pairs. The range is the y, so that would be, in a function, it doesn't matter if y repeats, we're only worried about the x. C. domain, and the range, the y values.
0, 1, 4, 8, 9.
Okay, so if we're looking at a table or a set of ordered pairs, it's not too bad. D is written a little bit different. So this says the set of ordered pairs x, y, such that y is equal to x minus 2. So it's basically every ordered pair where y is x minus 2. Could we list out every ordered pair here? I mean, we could start making a list. You put in 0, you get out -2. If you put in 1, you get out -1. Put in 2, you get out 0. Is this list ever going to stop? No. So we can't just write it all out. So is this going to be a function? Will I ever pick an x value that gives me 2 different answers out? No. So that means it would be a function. Domain. Is there any number we can't plug in? No. So in the past, we wrote that as all real numbers. If we do interval notation, we put a starting and a stopping point. If it goes forever in both directions, that's the all real number. The range, is there anything we won't get out? No, we can get positives, we can get negatives, we can get zeros, so the range is also negative infinity to positive infinity. That infinity is kind of like a sideways 8 if you're struggling to draw that tool circle. Questions on how to tell something's a function from the order pairs or table? Let's practice. This is something you did last year, looking at graphs and giving the domain a range. On A, I apologize, I know it's kind of hard to see. It's actually just 4 points here. So the domain, that's the axis. Since it's not continuous, it's just 4 points, we're going to list them out. So what are my x values?
-2, -2, -1, 1, 4.
So for each of those 4 points, we just took its x value. The range is the y. So if I start at this bottom point, it had a y value of -3. Next point was at -2. Next point was at +3. And last one was at +4. B. Can I list out every single x and y on this? No, it's continuous, right? I mean, I could put in -1, -0.9, -0.999. When it's continuous like that, we can't list them, so we're going to do an interval, do a domain and range. Okay, domain is your x. So when you're thinking about this, think about like traveling along the x-axis. If I go from left to right, the first x value we hit is where?
-1.
-1. Do we actually hit it?
Yeah.
Yes, so it gets a bracket, -1, comma, and then we put the last one. So if we think about traveling along this, the last one we hit is 5. We hit it, so it gets a bracket. The range is your y, so think of it as going from the bottom up to the top. So if I'm coming from the bottom, this whole thing starts at, and it goes all the way to 2.
I can learn to understand you much better if I can get familiar with the way you talk.
Okay.
Siri, I'm going with you right now.
Do you guys understand the difference between when we list them and when we do the interval? So if it's just points, you list them. If it's like lines, that kind of thing, you have to do the interval. All right, C. So if I want the domain going from left to right, this is a line. It keeps going to the left. So this is going to keep going and hitting everything that direction. This keeps going that direction. What do we hit? And then these always get parentheses. Range. This end keeps going down, that end keeps going up. So what y's do we hit? The domain. So as I go from left to right, this is going in the negative direction, that's going in the positive. This just keeps getting wider. So what x's do we hit?
X is greater than or equal to 0.
That's the
It would be a
range.
comma.
It's going to
The
be
y.
negative. It's going to be the positive.
The range is the y. So think about from the bottom up. So this thing starts at 0 and keeps going up forever. So my range would be bracket 0, comma, infinity. How can you tell from these if they are functions or not?
The vertical line test.
Okay. So, when you're looking at a graph, if it is a function, it has to satisfy the vertical line test. So I want you guys to take a second. On the next slide, I have 4 graphs. Just on your own, figure out which of those are functions. So decide if each of these is a function or not. All right, so does the first one satisfy the vertical line test?
Yes.
Second one?
No.
No. Circle?
No.
This one, it's increasing, it kind of flattens out, but it never actually becomes vertical. So that one is a function as well. All right, did you guys do okay on those?
Yeah.
All right, when we're talking about functions, we usually write them in function notation. So when we're looking at equations, we don't see x and y. We replace that y with an f of x. So that f of x together is your y variable. When I say f of 2 equals 13, the 2 is my x, the y is my 13. So that means the order pair of 2, 13. So I just want to practice using function notation a little bit. So for each of these 4 problems, I want to find f of negative 1. What this means is if x is negative 1, find y. And that's all it's telling us. So it's easiest if you have an equation. When I ask you to do f of negative 1, what do you have to do? So negative 1 squared is 1. 1 times 2 is 2. 2 minus 9 is negative 7. When I give you ordered pairs, this means the x is negative 1. So you find the point when x is negative 1, and what's the y value there? Okay, when I have a mapping, my domain, that's my x. So when my x is negative 1, what's my y? T. When my x is negative 1, what's my y? So we're looking on this graph. When my x is negative 1, you find the point on your curve, and what's y? About 0.5 or 1/2. All right, I want you guys to take a few minutes and see if you can do these last examples. So I gave you a function, I'm asking you to find 4 things here. So f of 4, we plug in a 4, so we get 5 minus 8 or negative. B, f of a. So if you plug in an a, you get 5 minus 2a. Is there anything to do with that? No, so that's my answer. We can have variables in these still. We're not solving an equation, we're just seeing what that is equal to. So we're just plugging in an a. So f of a plus h, what that means is you go to your equation, you replace x with a plus h. If you distribute, you have to distribute -2. So you get 5 minus 2a minus 2h. The negative has to go to both of those terms. And D, if we plug in a 5x, 2 times 5x is 10x. So we get 5 minus 10x. So it's okay to still have variables. You don't just get a number answer every time on these. You could factor 5 and have 5 from C1 minus 2x.